Hello students, welcome to in 5 minutes. Now we will be starting with Fourier series solution for December 15. So first question is question number 1. B. Find Fourier expansion for f of x is equal to 2x minus 1 in 0 to 3. So we need to find Fourier series for this. So I define series f of x is equal to a0 plus summation n equal to 1 to infinity an cos n pi x by l plus summation n equal to 1 to infinity bn sin n pi x divided by l. So I start with a0 students. A0 comes to be 1 upon 2l 0 to 2l f of x into dx. So let's compare and let's find the value of l. So this is c to c plus 2l, so that is 0 to 2l. So we can say 2l is equal to 3, so l is equal to 3 by 2. L is equal to 3 divided 2. So let's substitute now. So a0 is equal to 1 upon 3 0 to 3 f of x is 2x minus 1 into dx. That comes to be 1 by 3 2 x square by 2 minus x 0 to 3. 2 and 2 gets cancelled. This comes to be 1 by 3. When we put 3, that becomes 9 minus 3. That comes to be 6 divided by 3, which is nothing but 2. So I got this as a0. I define an. An comes to be 1 upon l 0 to 2l f of x into cos of n pi x divided by l dx. So which is 1 divided by l. So that is nothing but 3 divided by 2. 0 to 3 f of x is 1 minus 2x, and this comes to be cos of n pi x divided by l. So that is 3 by 2 dx, so which you can write as 2 by 3. 0 to 3 1 minus 2x. This comes to be cos of 2n pi x divided by 3 dx. Let's integrate this. That comes to be 2 by 3. First is 1 minus 2x, that is u. Integration of v is sine 2n pi x divided by 3, and this whole gets divided by 2n pi divided by 3 minus differentiation of this comes to be minus 2. Integration of this comes to be minus of cos 2n pi x divided by 3 whole divided by, this is 4n square pi square divided by 9, where limits are 0 to 3. Let's substitute the limits. So I write an as, the constant was 2 by 3 lying outside. Now we can say students here, when I substitute 3 and 3 gets cancelled, sine 2n pi is 0. So first term comes to be 0. Second is minus minus minus, so I can say 1 minus lies, and this comes to be 2 into 9 divided by 4n square pi square. 2 into 9 divided by 4n square pi square, and then here I can write 3, so cos 2n pi, that is nothing but 1. So we can say this is upper limit. Let's substitute 0. So sine 0 is 0. So first term again it will be 0. Then there are 3 minus. So 1 minus is remaining. So 2 into 9 4n square pi square, because cos 0 is 1. So same 2 into 9 4n square pi square. So we can write 2 by 3. This comes to be minus 18 divided by 4n square pi square. This comes to be plus 18 divided by 4n square pi square. So I got an as 0. This gets cancelled and we can write an as 0.